Good morning, Algebra 1. This is semester 2, chapter 5, the Apex notes. Today we are going to start talking about probability and statistics. So the first thing is talking about quantitative data. So quantitative data is numerical data where it makes sense to average the data. So in quantitative data, we're dealing with numbers and we're going to actually to average them. There's also qualitative data, which is where you would break things up into like maybe how they look, so if we had apples, oranges, and pears, we wouldn't, necessarily do anything with how many of them there are, but we would break them up into groups based on, what they look like or what size they are. So with quantitative data, okay, so we describe quantitative data distributions in several ways. We're going to be talking about these, the center, the relative location or the percentiles, the spread, and the extreme values are the outliers. And like I said, we're going to be talking about all those, so you don't need to worry about, exactly what it is right now. So the first one that we're going to talk about is the measure of center. So there's 3 values in the measure of center. The first one is the mean. The mean is also known as the average. Okay, to calculate the mean, we are going to add all of the data values and divide by the number of values added together. And then there's just this little thing. It is mean to make you calculate the mean without a calculator. So just a math joke. So really the formula for mean, okay, this is the symbol for it. It's an X with a line over it. And the formula is all of the values added up divided by how many there are. Okay, but you're going to start seeing these little notations right here, this little E looking thing. It's called sigma. So sigma notation is another way to write the mean, especially when you're dealing with Apex. It uses the sigma notation in Apex, which is why we're kind of talking about it. So the sigma formula for mean is 1 over n, and then this sigma I equals 1 to n xi. Okay, so this is what it means. So that means that we're multiplying 1 over n times, and this piece right here means the sum of all values from the first one to the last one. And so it's really the exact same thing as this. It's just written a little bit different. Okay? So the next measure of center is called the median. And the median is when numbers are listed in numerical order, meaning from least to greatest. The middle value is called the median. If we get to the middle and there's 2 values, not just one, then we average those. Okay, so add them together and divide by 2. And that's how we would get the median. And the last measure of center is the mode. And the mode is the number or numbers that appear the most often. All right, so let's take a look at this example. It says students in a math class were asked, how many minutes did you spend working on homework last night? So a random sample of 10 students resulted in the following data. Okay, so we asked 10 students, how much time did they spend working on homework? And these are the values that 10 students gave us. So the very first thing we're going to do is I always like to write these in order first. Okay, so I'm going to look for my smallest value, so 0, then 2, then 10, then 20. And you see I'm crossing them out as I go so that I don't miss any. Okay, then 60, then 60 again. And it doesn't matter that 60 is used 3 times. We're writing it all 3 times in there. Okay, and then we have 90 and 150. All right, so now we've got all 10 values. So the first step is going to be to find the mean. Okay, so to find the mean, I'm going to add up all of these values, 0 plus 2 plus 10 plus 20 plus 30 plus 60 plus 60 plus 60 plus 90 plus 150. And I'm going to divide by how many numbers there are. There are 10 of them. So when I add those up, I get 482 divided by 10. So my mean is going to be 48.2. And in other words, that's my average of all of those. It doesn't mean that it's the number in the middle of the group. It's just my average. Now we're going to do median. So median, what I'm going to do is I'm going to start on both sides and I'm going to kind of count in. So 0 and 150, 2 and 90, 10 and 60, 20 and 60, and 60 and 30. So right there is my middle. So if it was just one number here, then I would be able to just write that number down. But because there's not, I'm going to have to actually average these two numbers. So I'm going to say 60 plus 30 divided by 2 equals 90 divided by 2 equals 45. Okay, so 45 is my median. And then my last measure of center I'm going to find is my mode. So this is the number that appears the most often in our list. So if we look here, 60 appears 3 times, which is more than any other number. So 60 is my mode. All right, so now we're going to talk about percentile locations. So, and we're going to continue using the same data set for our examples as we continue on. Okay, but now we're talking about percentile locations. Okay, so when we're using the median as a measure of center, the data is divided into a lower half and an upper half. Okay, so I'm going to go ahead and write these out again in order. Okay, so 0, 10, 20, 30, 60, 60, 60, 90, and 150. And remember that we said, oh, I forgot 2. That's why it looks a little bit weird. All right, so 0, 2. All right, so remember we said that our middle was right here. Okay, our median here is 45. Okay? So what we're going to do here is we're going to divide the data into a lower half. So this is my lower half and my upper half. So those are my lower and my upper. But now I'm going to divide those further into quartiles. So think about quarters. So a quarter means it's going to be the breaking it into half again or into equal fourths. Okay, so now if I'm looking at my first quartile is the median of the lower half of the data. This breaks the data up into 25% below the value and 75% of numbers will be above the value. Okay, so now I'm going to look at my first quartile. I'm going to look at just my lower half. Okay, and I'm going to find the middle of my lower half. So 0 and 30, 2 and 20, so 10. Okay, so that is my first quartile or my first IQR. Okay. So, and we're going to talk more about IQR here in a minute. Okay, so this is my first quartile. Okay. So what we see here is we see 25% of the total data is to the left of it or lower than it, and 75% is higher than it. Okay, so now we're going to look at the third quartile. So the third quartile is the median of the upper half of the data. This breaks the data up into 75% below and 25% above. Okay, so same thing. So now I'm going to find the middle number, okay? And that is my third quartile. And just like with our median, you know, if there were 2 numbers in the middle, we would still have to average them just like we did. Okay, so here we've already done this question. So it says our first quartile is 10 and our third quartile is 60. Okay, and really 45 is our median, and that would be our second quartile, right? Because there's 1 quarter, there's 2 quarters, there's 3 quarters, there's 4 quarters. Okay, so we've just broken this thing up into 4 equal pieces. All right, so let's go on ahead and let's look at what we're going to do with these quartiles and values that we get. So the measures of variability. So how far spread out is our data? So our data could be really close together, or we could have numbers that are way spread apart. Okay? So the range is the difference between our lowest value and our highest value. Our interquartile range, and that's what I was talking about, we're going to be using our first and third quarters for, is the difference between our first quartile and our third quartile. And then our standard deviation is going to be the average distance of the values from the mean. And we're not going to calculate this right now. We get into it in a lot more detail in statistics and also in Algebra 2. But for right now, we're just going to tell you what the standard deviation is. All right, so now I'm just going to find my range. So my range, looking back at the previous values that I've done, is just my highest value in my set, which is 150, minus my lowest value, which is 0. Okay, and that's going to give me a range of 150. My interquartile range, my IQR, is going to be the difference of my first and my third quartiles. And remember, we said that our third quartile value was 60 and our first quartile value was 10. So our interquartile range is 50. Okay, and what that means is when we're looking at our data, 60, 60, 60, 90, and 150. So right, was it right there? No, it was right here. So this is our third quartile, and this is our second quartile. So the range between those two, or between those two, is 50, and that's our IQR, okay, our interquartile range. Okay. And we're going to use this IQR to find what's called outliers. So anytime, we're talking about values, you can see that most of these are around 0 to 60, and then there's this one that's 90, so it's a little bit bigger than the rest, and then there's this one that's 150. So the ones that are really big and don't fit in with the rest of the data are called outliers. And a lot of times when you're doing science experiments and stuff, sometimes you'll get a bad data point and you're gonna exempt it from your data. You're gonna say, something must have been wrong with this. So this really does relate and play into science as well as math and statistics, because these are data points that we don't want to include because for some reason they're way different than the others. Okay, so it says a value that is very different from other values in a data set. That's what an outlier is. It can either be really large or really small compared to other values. So we have two different ways to tell, or two different things we're going to look for. So we're going to look for any value that is 1.5 times that IQR, which we just calculated, smaller or lower than the first quartile, and any value that is 1.5 times IQR higher than the third quartile is an outlier. Okay, so here's what we're going to do. So we're going to find our first quartile, okay, and that was 10. So we're going to say 10 minus that 1.5 times our interquartile range. So that's going to be 10 minus 1.5 times 50, okay, and that's what we found up here. Okay, and that's going to equal 10 minus 75, which is negative 65. Then we're going to do our third quartile, okay, and this one we're going to add that value. So our third quartile is 60, and we're looking for anything that is extremely larger than that. So 60 plus, and we're going to do that same thing, 1.5 times 50. So it's going to be 60 plus 75, and that equals 135. So now we're going to come here and we're going to look at the data set. So negative 65, are any of these numbers smaller than negative 65? Okay, no. So there are no outliers that are smaller. Okay, but now we need to look at this value, 135, and are there any values that are greater? So remember a minute ago, I said 90 looks like it, is kind of far away, and 150. Well, 90 actually is not an outlier. It's close enough to be considered good data. However, 150 is bigger than 135, bigger than 135. So it is an outlier. Okay. So if we were doing a science experiment and we got these values, 150 would be thrown out, okay? Because once again, that would mean that for some reason, it's a whole lot bigger than all of the other values. And so we don't want to use it. Okay, so outliers, okay? A whole lot smaller or a whole lot larger. And I put small here, but it really should have been smaller. Or small, I guess. Really small compared to all other values. All right. So that's it for 5.1. Have a great day, and I will see you all next time.